Okay, so we'll be going over lesson 5-6 here, solving equations with radicals. Okay, we will do this first video will just be kind of simple equations, and then after we do that, the next video we will move on to some more complex examples. So starting out with, we need to recall, what does the graph of y equals the square root of x look like? Well, if we remember, okay, y equals the square root of x. Okay, we only look at 3 points for this one. Okay, if x is 0, what is the square root of 0? Well, it would just be 0. Okay, so we have the point 0, 0 here. Okay, if we have x equaling 1, what is the square root of 1 here? Well, it's just 1. Okay, and then if we have the square root of 4, because remember we didn't want to use 2 because we don't know what the square root of 2 is, but we do know that the square root of 4 is 2. So 4, 2 is the last point on here. And this graph is just a little ray, I think is what you guys called them in geometry, meaning that it does not go past that point 0. Okay, and there we go. That's our example there. Okay, so that is our parent function for y equals x. So what do we know about the inverse of this function? What do we know about the inverse of this function? Well, if you guys think about what we've been using square roots for, we just went over our quadratics unit. Okay, remember if I had x squared equals 9 and I was trying to get rid of that squared, I would square root it. Okay, and we said that squaring something is the inverse of the square root. Okay, so the inverse of this is y equals x squared. So real quick, if we remember what that function looks like, that function ends up being our parabola. So what is different about our parabola and our square root function? Well, obviously, one of the differences is that the parabola, is making that U shape, and then the square root function is on its side. But the other main part is, that I hope you guys would realize, is that the parabola makes that U, meaning it's got 2 arrows on it, and our square root only has 1. So what happened to the bottom part of that square root function? What happened to this section of that square root function right there? Okay, well, if that part of the square root function was there, this thing would no longer pass the vertical line test. So essentially what they did was they had to get rid of that part of the square root function in order for that to still be a function. Because if that bottom part was there, you could not run a vertical line through it without it hitting twice. So they got rid of it. Okay, and that is part of the reason that we have domain concerns with this function. And that will also result in this function having something called ghost parts. Ooh, spooky. Well, I don't know. Maybe the ghost is more mad because it's scary. Yeah, there. Spooky ghost parts. So essentially what's going to happen is sometimes when we deal with these square root functions, we are going to get answers that are not actually answers to the equation. And that comes from these ghost parts here. Okay? So, pretty exciting stuff. And what that means for our ghost parts is that you must check your answers. Okay? And this is not like when you were in middle school and were first solving equations and you had to go back and check them because Mrs. Lucas or Mrs. Lewis made you go back and check them. This is because you will do all of the work correctly and you will get an answer, but because of those ghost parts, it is not actually an answer to this question. Okay? So, let's go through here and let's work through a couple simpler examples. So, first one we got here, we've got square root of x plus 1 equals 2. Okay, now, we are trying to get x by itself. And what is in the way if I'm trying to get x by itself here? Well, that big old square root sign. I cannot subtract by 1 yet because that positive 1 there is in the square root. So the first thing that I need to do with this problem here is I need to get rid of that square root sign. And to do that, we're going to need to use the inverse of a square root, which would be squaring a number. So when I see a square root, I need to get rid of it, and I will get rid of it by squaring that number there. Okay? If I square one side of the equation, though, I must square the other side. Now on this left side here, the squared and the square root will go away, leaves me with an x plus 1, equals, and then on the right side I have a 2 squared, which gives me 4. Now I'm just going to solve it just like normal. Subtract 1, and I end up with, sorry, I blanked. I end up with x equals 3. Now, can I circle that answer? No. I have to check and make sure that this is okay, because what could happen is I could have had this line run through some of those ghost parts and give us a false answer. Okay, it's actually called an extraneous solution. Okay, so I must check. So I'm going to take my x equals 3 here, and I'm going to plug that back into my original equation. So I will have the square root of 3 plus 1 equals 2. And now I'm just going to simplify. 3 plus 1, well, that just gives me 4. So I have the square root of 4 equals 2, which is true. The square root of 4 does equal 2. So I can go ahead and circle that answer. Okay? When you were in middle school, they made you work it all the way down until you got 2 equals 2 to prove it. You don't have to do that. I trust that most of you guys know what the square roots are at this point, but you do need to check and make sure that that gives you the correct answer. Okay? Next, we've got the square root of x plus 5 equals 4. So notice the plus 5 is not in the square root. Okay? So for this case, I could subtract by 5 if I wanted to at the start, because that is not in the square root. Okay? However, we just went over this, and a lot of you guys are going to say, oh, let's square it to get rid of that square root. Okay? Now, if I do that, though, the square root of x plus 5 squared, that literally means, if you are squaring that, that means that you need to take the square root of x plus 5 times the square root of x plus 5. Does that look like fun? No, because we would have to FOIL square root of x times square root of x, square root of x times 5, 5 times the square root of x, 5 times 5. Okay? That does not look like fun. Plus, that is not actually going to get rid of the square roots like we want it to. Okay? So for this case here, we actually do need to subtract by 5 first. Okay? And I want you guys to notice the difference here. See how that plus 5 is not underneath the root? And see how this plus 1 is underneath the root? Okay? We have to get the radical isolated first. We have to get the radical by itself first. So in this last example here, the radical was by itself already. It was the only thing on this side of the equal sign. So that's why we had to square it then. Whereas this example here, there is a radical and another number over here. So our first step, and you guys want to star this, is to get that radical by itself first. Okay? So for this one, my first step is to subtract by 5. Then I get the square root of x equals a negative 1. Now I have the radical by itself. So now I can go ahead and square this, which gives me squared and the square root cancel, so I'm left with just an x equals, and this negative 1 squared means negative 1 times negative 1, so that would give me a positive 1. Can I go ahead and circle my answer? No. You must check. You must check. Okay? So I need to plug that 1 back into the original equation. So I've got the square root of 1 plus 5 equals 4. What is the square root of 1? Well, the square root of 1 is just 1 plus 5 equals 4. Is that true? That is not true. So x equals 1 is not a solution. And that is not because I made any sort of error up there. I did everything correct. But this function is not a solution. Okay? So what's our answer then if x equals 1 is not the answer there? Well, x equals 1 is the only answer that we got, and we found out that that is not true. So our answer for this one is no solution. There is no solution for that problem there. Okay? And that's all we have for the first video. Next video, we're going to deal with a little bit more complicated types of problems.